Welcome back. Now we're using multiplexers to implement a function. We are in the practice number 7. So first of all, I'm going to explain the task description. The goal of this project is to design and implement a digital logic function using the multiplexers on the FPGA. So multiplexers are essential for effectively selecting between multiple input signals to produce a desired output, making them an ideal choice for implementing complex logic functions. So the project will leverage the Intel Max 10 FPGA to handle the interactive switching logic involved in multiplexer-based design, showcasing its effectiveness in high-speed digital operations. So I'm going to explain the development of the VHDL code. So the code represents a VHDL implementation of multiplexer function. So it takes three inputs. They are labeled by X, Y, and Z combinations, and them into selective line that controls the state of the 8 output signals. So we have D0 to D7, which represents inlets. Initially, all outputs are turned off by setting them to 0. The values of X and Y and also Z are concatenated to form a 3-bit select line that determines which output will be activated, based on the combination of these three inputs. A case statement is to light up a specific LED. So, as you can see, all the scenarios are set to 0 initially. So, all LEDs are turned off. But in the case which is how it will be behaving, this program in the FPGA are set in the following ones. So as you can see, some specific cases such as 001, 011, and 100 result in no LED being turned on, showing that not all combination of the inputs produce a corresponding output activation. Therefore, the code allows for selective control of the LEDs, depending on the values of the three input signals. So, for example, when the select line is set to 000 or X in 0, Y in 0, and Z in 0, there are the, the output signal set to 1. So similarly, other input combinations correspond to different LEDs being turned on or off, depending on the scenario. In this case, we are having these um, output signals because we have a truth table that corresponds to these signals, and that will help us to have the desired output signals for our specific design. So you will have to watch out what is your truth table. So you will have to turn on or off the output signals depending on your design. So I'm gonna jump to the physical part so you have a better comprehension of what we're doing here and you understand more about the truth table.
Hey everyone, so now we are on the practice report number 7 using MOOCs to represent a function. So here we are on the physical part of the video using the FPGA Max 10, and well, these are the switches. So we're only using three switches here. That will be C, X, and Y, going from less significant to the max significant bit, to the most significant bit, I mean. And what is going to happen is that it's going to turn on LEDs depending whether if it's on the function table, well, I mean in the truth table or not. So here is our function, our truth table. So whenever the three of them are on 0, the is going to be 1 on the function. So right now the three switches are on off and the output is 1, and if C is on 1 the output is gonna be 0. So let's put the first one 1, and as you can see the LED turned off. Now let's see another case. So if the Y is on 1 the output is going to be turned on. So let's go and do that. There you go, the output is turned on. Now let's go with a new scenario here. So let's put the X on 1, the Y on 1, and the C on 0. So that's the case, and the LED that is going to be turned on is the 6. And we have a 6, of course, in the input is 0, 1, 1, as in the truth table. And if the 3 of the switches are on, that will be 1, 1, 1. And the LED that is going to be turned on is the number 7. That represents a 1, of course. So I'm going to do that to the final case. There you go. So that's everything.